every acre of annual crops in the USA, North America, around the world gets restored, ecologically restored back to its previous plant community type and ecological function, including hydrological function. And that's a small change. Modern agriculture is in a state of model collapse. The researchers study a flawed system already, which is an orchard, which is 100% apples of the same clonal variety. So they're studying a flawed system. Then they generate results. And then the next research that comes along, they're adding the flawed results back to the flawed system again and again and again.
Welcome back to the Soil Talks podcast. But today we're zooming out. Mark is the man who proved that you can scale permaculture to broad acre farming without losing your shirt or your sanity. Mark, welcome to the show.
Well, thanks for having me.
Why do you believe annual monocrops like corn and soy are a war against nature, and how perennial polycultures like trees, shrubs, grazing, like we kind of just talked about, offer kind of that peace treaty?
Well, what I want to do with that, the way that question was asked, it was asked and it threw in a lot of concepts. I want to frame this from the perspective of observable reality. What are the actual things that we're actually seeing? So I'm not talking about corn versus chestnuts. Corn and chestnuts are both high carbohydrate, low oil, low protein. You know, they're a grain. Chestnuts are a grain that grows on a tree. They have fundamental differences in how you grow them. Corn is an annual grass. The seed requires a good soil to seed contact in order to sprout and grow. It needs minimal competition in order for it to grow. And so what that ends up happening is you have to, if you have a grassland, historically, you'd have to plow up that grassland to get your corn to grow. Then every time the weeds keep coming back, that's nature trying to reclaim the site. You have to get rid of those weeds somehow, either through cultivation or through chemistry. And so that right there is a fundamental difference in order to grow carbohydrates that way than a chestnut. A chestnut, yeah, you'll want to have good soil to seed contact. You put it in the ground, and then it needs a little bit of care for the first few years to get past the grass competition. And then it dominates the site. And then it doesn't need disturbance to keep coming back year after year because it's there for the next 100 zillion years. So there's just a fundamental difference between the two ways of growing that carbohydrate. And if you look at corn and you think about disturbance, there's places where, you know, herds of bison went through. There was a flood that deposited silt. There are places and there are reasons and needs to have annual plants because of disturbance. However, when you disturb 50% of a continent to plant annual crops, you lose the ecological function that the plant community, the perennial plant community, whether it was grassland, savanna, or forest, you lose the functionality of the ecosystem. So with the restoration agriculture approach, we use both. You know, a lot of people overlook the fact that I've grown annual crops here for like 25 out of the 30 years that I've been here. And the reason why I don't now, because it's an incredibly expensive way to grow food. I was certified organic, so I'd have to plow the ground, disc harrow the ground, do cultivation 2-3 times a year. Then you go out and you harvest it, so all the expensive equipment. Of course, maintaining the soil health and fertility, you just have to pay attention a lot more closely and do things in a particular sequence of timing and do it appropriately in order for your annual crops to grow. So as soon as I could drop that, that's an expensive way to produce food and crops for sale. As soon as I could just go completely perennial, that's like, why would I do anything else? It's awesome.
And that's great to see that you have operated both ways. You did mention something also about the weeds coming in and Mother Nature kind of healing itself. We worked on some projects in oil and gas on reclamation work and things like that. And we were going in and helping them restore those, right? Taking biologicals and different things, cover crops, and planting them on there in order to remediate the soils. But when we would come across land farms that had weeds growing on them, we would check those land farms and they were 100% clean. Mother Nature had already done her job, and so
why should I try to kill the things that want to live? And why do I struggle to keep things alive that want to die? Let the things die that want to die, and I'll work with the ones that want to live. And so I kind of backed into the ecological restoration side of it. But you think about that over long, deep geological time, the plants that would survive where you are adapted to that place, whether it goes into a drought cycle, a wet cycle, cold cycle, hot cycle, 4 or 5 different ice ages. Those plant community types are adapted to that place. They have the genetic information hardwired right in them, how to survive all of that. And all we have to do is work with that. It's a beautiful platform to start from.
Uh-huh.
All right. What it will do is it will require you to think differently. I just was talking about somebody that brought me to their operation. They had sheep enclosed in a old derelict apple orchard. They weren't harvesting the apples anymore, and they weren't making any money. And they were looking at their sheep operation as this closed unit within their farm. And I said, well, here's what we do is we now integrate your whole entire farm. We redesign your whole entire farm, and the whole farm will become profitable. And they're like, nope, we want you to show us how to make the sheep profitable on this spot, on this location. And it's like, it doesn't work that way. It's not that simple. We have to design a complex ecosystem, and it's going to require the other parts of the property in addition to this one little square that you have fenced off.
Can you kind of define the difference between a sustainable agriculture and restorative agriculture for me?
Well, sustainable, if you think about that, that's what are the practices required to sustain what you're doing right now in perpetuity? You're kind of holding it steady and holding it in place and not degrading it. Restoration, on the other hand, ecological restoration and basically what it is going to a area and restoring the plant community types that used to be there historically over a long period of time, and the ecological functions that happened at that place, and the hydrological relations that were happening on that place. And most commonly, and one of the reasons why I intentionally chose that for the title of my book, is that most commonly people say, well, hey, look, you either get agriculture or restoration. You can't have both. And so we can't afford to take land out of food production to restore it back to an ecosystem that once was, because we'll starve the rest of the planet. And that's not entirely true, because what we're going to grow there are going to be different crops. This goes back to our previous little discussion. It's like, in order to grow things here almost effortlessly, I have to let go of corn and beans, because they're not effortless here. They take a lot of work to grow here and a lot of equipment and expense to grow here. Whereas the oak savanna plant community types, those plants are growing so fast and so vigorously that literally I have to go after them with chainsaws and tractors to get rid of them, because they belong here, they thrive here. And so we're restoring the ecological function. What goes along with that is now you get all of the wildlife, the insect life, the birds, the animals, reptiles, amphibians. And if you think about birds, for example, most birds anyways have insects as a high percentage of their diet. Well, what are the birds doing in your ecosystem? They're doing insect control. So why would I want to eliminate their habitat when now I'll have to go take care of the insect control? Same with amphibians. Well, they need water in order to reproduce. So let's manage any runoff water and have pocket ponds here and there specifically for amphibians to reproduce in, and as watering stations for livestock, so I don't have to have tanks and pipes and hoses. And now I've got amphibians that are helping with insect control. Why would I spray insect control spray to get rid of insects when I know that amphibians get 50% of their oxygen right through their skin? So if I use an insect killing spray, whether it's chemical or certified organic, it's making my frogs sick and killing my frogs. So why would I kill my insect control in order to get insect control? It just doesn't make sense to me. doesn't that seem like a bit extreme to go in and now start cutting stuff down and chipping it all up, and or taking trees and logging them and turning them into lumber? It's like, well, if you look at disturbance, natural disturbance, fire is a big, huge part of most ecosystems around the world. When a fire comes through, all of the carbon is exported from the site, except for the little bit of debris that's left behind, whether it's ash or just shredded wood. So to remove the carbon isn't necessarily an ecological bad thing to do, because nature does that on occasion as well. You can have more stems per acre. We can actually have a faster growing woody plant community than if we just left it alone. So when we go in and manage the woody component of a ecosystem, we end up having a healthier, more vigorously growing woody plant community and more useful forms. The trees are growing straighter and taller, et cetera, et cetera. And it pays for itself because we're producing high quality products.
Let's move on to the water side of things. Keyline design. Let's dive into the concepts from Water from Any Farm. That's your book. How do you use keyline systems to move water from valleys to ridges?
The term keyline design was crafted by P.A. Yeomans in Australia, used to describe a pattern of land use that I'm going to actually show a demonstration. I've never used a rolled up face cloth before, but I'll use it. If you have here's a hillside, right? And if I pour water on me, it's going to run straight down. Or I can either farm across the slope, or I can make channels across the slope using various different tools. And if this is a channel 1 foot deep, 100 foot long, and the water comes down this way, what's that water going to do? It's going to sit there on contour, and it's going to soak in, so that water no longer goes down to the valley and floods out the valley. So there's a little bit more water up on the hill, and it adds up over time. Well, the keyline cultivation pattern, as described by Yeomans, is you start at what's called a key point, and you go right there where your collarbones come together. Yep. Or in a valley system, you go up to the head of the valley, and all of a sudden it's not valley anymore. It's kind of like that headlands above it. That's a key point, that's a key point, and that's a key point. At the key points, now you take a contour line from that key point. So now we've got this channel is now on contour. And then that's our key line. And then in the valleys, if you go ahead and have your equipment pass parallel to that as you go down the valley, in theory, according to Yeomans, those lines now pitch this way. So what happens now, the water comes down, it spreads out from the valley to the ridge.
Sure.
That's a really cool idea. Unfortunately, that only works on a simple landform.
Sure. Yeah. So getting those two manuals that you actually authored, that pretty much will set you on the path that you need in order to make it happen.
Yeah. And I would recommend getting the blue one first, just to get a full understanding. Say, okay, yeah, I get it now. And then when you want to go put it on the ground, then go get the brown one. And before you get the brown one, I would spend about a week on a high fiber diet, because this is all the engineering diagrams and the math and stuff like that. And if that's not your thing, it will constipate you. It's boring.
All right. Yeah, no. And like you said, get it from Acres USA.
Correct.
Let's discuss hydrology as architecture.
The planet and the way that the rainfall interacts with the planet could care less where you want a pond. Yeah, but that's the wet spot. It's like, well, the reason why that's a wet spot is because all the water ran off your dry spot over here and wasn't managed properly. So if we start and we design a system that captures whatever water comes down, spread it out, soak it in, direct it to certain locations, by doing the design on the ground of the water management system, it will show us where to put the pond, where to put the house, etc. Water drives the shapes on this planet. It's just amazing.
That's cool. I never looked at it that way, but it's a good analogy. Yeah, let's talk about the stun method.
I kind of backed into the stun technique and realized that that's how nature operates anyways. I encountered it because, I go out and I plant 100 trees because that's all I can afford. And then next year I plant another 100 trees, and planting these trees and taking care of last year's trees and taking care of the last ones, pretty soon I can't take care of these other ones anymore. And I realized that the ones that I didn't take care of at all were doing okay. They weren't doing as well. And then was like, was it really worth all the effort to get these trees to grow really, really well? And what I found out over time is like, no, it wasn't, because the trees that weren't adapted to my soil types and the soil chemistry, the rainfall pattern, whether it's hot or dry, cold or wet, deer browse, a lot of deer browse, the ones that couldn't survive here died. The ones that did survive, they had something genetic going for them. They knew how to survive, and they could survive and thrive. Well, then out of those, I would go find the ones that produced fruit or seed earliest in their lives. Then I save that and replant those. So now I'm focusing the genetics for early reproduction. Well, then the trees that are really young, they're getting, the early reproduction's getting replanted into the system. Well, then if this tree right here produces more than the others, it has more seed represented in the seed lot. So now I'm selecting for high productivity, early reproduction on all, and then high productivity. And as you keep doing this over time, let the losers die, and then keep concentrating the ones that reproduce fast, that reproduce the most, that are most pest and disease resistant. And what you're doing is you're breeding adaptability to your site the way it actually is, instead of, oh my gosh, here comes a bug, I better spray, or oh no, here's a disease, I better kill it. And it's just it's a radically different approach. And the breeding technique, of course, once again, I back into it to find out about it. It's called mass selection and breeding. It's open pollinated. And what mass selection breeding does, and that's how nature does it, is it's selecting for population fitness. This population of apple trees, for example, is perfectly fit on this farm. There are high performers and low performers. What we didn't do is we didn't breed for individual performance, that, these high performers that out yield everybody. Because if you get these high performers that out yield everybody, now you take them out of the context that they were grown in. Now you have these race cars that are now susceptible to everything under the sun that's coming in after them. And you've thinned out your gene pool. You've restricted the different variations that could happen. So we will have high performers in our gene pool, and we'll go ahead and propagate more of those. I have a hazelnut variety, gigantic hazelnut on it, called Rosie. And so I probably have 300 or 400 Rosies across the farm right now. I use those as my prize bulls. They're going in and they're servicing all the different cows because I like the traits that Rosie has, but I don't want to get stuck with too many Rosies, because then it would be Rosie driving the genetics of the system, and Rosie does have some faults that I don't want to propagate through the system. So we breed for population fitness first, not individual performance as the goal. What is it that you really want as a farmer or a rancher? Do you want yield, or do you want net profit at the end of the season? That's what I'm at. So we want a net profit. So let's leave yield out of this in one sense. It's not about that, because if you're getting a yield of 100 units per acre and it costs you 90 units per acre to get that 100, your margin is 10. If I only get 50 units of yield per acre, but my cost is 1, I have 40 net in my pocket. So I have 4 times as much as you for 90% less work. That's from the yield side of things. Well, another one on the yield side of things, let's take, I'll use a simple example, an agroforestry system with black walnut for timber and nuts to sell to the nursery industry, and corn. And the reason why I picked that is because some of the pioneering research, agroforestry research in the USA was done on that system exactly. So if I take an acre of ground and every 50 feet I put in a row of black walnut. Because of the wide spaces between it, I'm able to get sun on all sides of those black walnut. I can fit in approximately 50% of the walnuts that I would plant as I would on an acre. So if I planted that acre completely to walnut, that would be 100% walnuts. That's a factor of 1. I'm only going to put in a 50% of the walnuts, so that's 0.5. So automatically I've told you how to get lower yields in walnut. Okay, now corn. If we had 100% corn, that's 1. Well, we took 20% of the land away from the corn to plant the walnuts. So now we only get 0.8 corn. So now I told you how to get a lower yield of corn. So by getting 0.8 of a yield of corn and 0.5 of a yield of walnut, that's 1.3 total site yield. Ecological research has shown over and over and over again that it's the total number of species per acre that results in the highest net photosynthetic productivity. And that's the amount of sunlight that comes in minus the metabolism of the plants. That's the product that's left for yield that we can harvest sustainably forever, and the system will keep coming back. We look at what's growing really well in the area around you and say, oh, okay, then we'll pick these, and we'll only take like 3 or 5 of those and plant them in the ground. And then the ultimate market happens to be this really cool little animal that has a little short feet, this little flat, wet nose. It's called pigs. We were able to raise them here on about 135 pounds of feed, of purchased feed, to get them up to market weight. And usually it takes close to a ton to get them up to market weight. Things like if we're harvesting apples and pressing cider, we have a lot of the apple squishings that are left over. So that stuff that we harvested, then we go dump that in. After we've finished harvesting a block, they go in and they clean up off the ground afterwards too. So they're doing both, delivering it to them and cleaning it up. With the hazelnuts, it's a similar thing. We'll harvest the hazelnuts. It's like a mid-August kind of thing. And then we do the processing here. We're husking them, sorting, sizing, put them in bags to get them shipped out. And then they get the cleanings that come off the cleaning machine, and they kind of snuffle through that. And then we turn them loose, and they go clean up the stuff that we missed that's out in the field. And so then with produce, that was a fairly regular thing because as we're harvesting, so I do have 2 acres of asparagus. So I do 2 acres of asparagus in the springtime while I'm getting my summer crops in. Then I do some sort of squash, mostly acorn squash and pie pumpkins. And then green peppers were another one. So after you go down, you're picking peppers, if it's got a hole in it or a spot or, whatever, I go down the road, you go left out, right in, left out, right on, left out, right on. And so then I go down, then you turn around and come back. The left ends up being the same thing, and those are all the ones that are flawed. Then I just go down with the front end loader and put them in the bucket and go dump them to the pigs. And the same with the squash, is they would get all the squash and the pumpkins and clean those up. And one of the really neat things about pumpkin seeds and squash seeds is they're actually a parasiticide. So in the last month or so before they go to market, they're getting dewormed from all of the squash and pumpkin seeds. And then they go on to the chestnuts, and then they plump right up.
How can a farmer transition from, say, 1,000 acres of corn to a restoration model without going bankrupt in year 3? Is there a way to do it on a larger scale? When I say scaled, say 10x what you started with. Is there a way to do it, Mark?
Yeah, there is. And actually, people know about this place because this is, this was done 30 years ago, and it's the most mature. I had actually I had 4 properties before I ever got to this one, and I was learning. So now that I got to this one, this was when I hit my stride. And now there's a total, as of last year, I had 13 different properties, over 600 acres under management. Now, what I want you to do is look at the brush on the side of the road. And then I will ask you, how much work did you do in order to maintain the brush on the side of the road? Very little work. So all these other properties that I have, there's one that's only 20 miles down the road. I haven't been there in a month, 2 months. I don't have to. I mean, it's a wild system. It's doing okay. When it's harvest season, I got to harvest my buns off, and I'm busy during the harvest seasons. So how do you do it without going bankrupt? Is you If you are in a situation where you're in the process of going bankrupt or just about to go bankrupt, it may be too late for you to turn it around easily. So here's another mathematical economic reality. If you are losing money on your IRS Schedule F farming enterprise, okay, I can give you an infinitely incalculable rate of return on your investment. Because if you lost money this year, next year, you're not going to do a damn thing. You will have zero inputs and zero profit, zero income. That's zero. That's called break even. Whereas you were losing. And so I took this losing number up to break even with zero investment. That's brilliant. Well, that's not going to cash flow if you need the cash flow from your operation. So if you have extensive holdings and you want to do a transition and you're about to go bankrupt, sell one. Sell one, use the capital. I would encourage you to redesign the whole entire, what's remaining, do the water management first, do the whole redesign on it all, and get everything planted all at once. Because the critical 3 years, the first 3 years are the most critical, getting the grass established on your water management system and getting your trees established. You may have to bring in supplemental irrigation. So it's going to take a little bit of work to get through those early 3 years. And then after that, it just the work just drops off, significantly. So that's one way to do it on a larger scale. Whereas I've done it on the other way around, and I'm going to use another analogy. If you look at a steam piston on a train, right? It's only this big and it's only this long. And unlike a gasoline car where you can like pour more gas into it and it goes faster, you can only run so much steam through this pipe and it only goes so fast. But you have what's called this flywheel effect. And you go ahead and you get it going. You get it going slowly. And once that flywheel is spinning and it's up to speed, so now you get your system so it's here, it's established, it's going to be okay. You take a belt and you slip it onto the flywheel on the one next to it. And that same steam power can now start driving that one and the one that you're on. And you can keep doing it until the friction in the system is so great that one little input, that one little steam piston can't do it anymore. And so why I mentioned that is the original amount of borrowing that I had to do in order to acquire this property here was all that I ever borrowed. So you pay it off for a few years. So that means you're amortizing that mortgage. The property, actually, you're getting a deduction because you can depreciate all the different things that you put on it. So your depreciation actually counts as an income. And then the property becomes more valuable because what I am doing when I am here, I am going to focus my resources on making that property more valuable. So that's the appreciation of the property. As the property appreciates, you amortize that note, and you've got all the benefits from the depreciation expense, which goes into making the property more valuable. Pay money for 5 years, go borrow it back. Then I go pay money for 5 years, borrow it back. Pay it for 5, borrow it back. That's the steam piston, over and over and over. Then once you get to the point where all of a sudden now it's fully developed site, you flip the belt onto another property and you do the same thing. And you just keep rolling that debt forward, and you leave the paid off properties behind you as you go through time. And it's just math at that point in time, is to figure out how to do that and plant trees. We're playing the long game here. I'm thinking on a crop rotation of 1,200 years.
Can farms out here, just regular row crop farms that use furrow irrigation, can the guys out here or anywhere in the U.S., it doesn't just have to be here in Montrose, but I'm thinking about the guys that we work with, families that we know here, can those guys actually turn over just literally row crops ground that's furrow irrigated? Yes, they have water on it. They have shares of water. It's watered ground. Can they turn those types of systems into a restoration agricultural system like you do?
Oh yeah, and the first step that we would do is a redesign of the water management system on the ground, because it'll still be linear, but it won't be rectilinear. It will be curvilinear, because it's more based on the actual shape of the land. Each one of them is a custom design based on, the crop types that the landowners are doing, the preference of the landowners.
Let's talk a little bit about your company, or a little bit more about it. Restoration Agriculture Development, or RAD.
Restoration Agriculture Development is a consultancy, and it's a design and install company. So we will either do like online consulting or in person, and then once we do an in person, we kind of have a 3-step process. We do the first site analysis, and we kind of figure out what are your options. This is what you're doing. These are the things that you want to accomplish. How can we help you with the design to get there? Then phase 2 would be the water management system design and install right away. We go out, we survey it, we design it on the ground, we install it, and it's functional when we leave the site. Then phase 3 is planting the trees along with that. And so, RAD does all 3 of those stages. And then in some cases, what we'll do is we'll have follow-on maintenance through time. So RAD is more the consulting, design, and install of the water management.
At this point in time, I believe it's starting to gain more and more steam, but why are more farmers not doing this exact thing yet?
I think for one is that they don't believe it. They'll go ahead and read it or hear it and say, yeah, that sounds like a good idea, but it won't work for me. So it's just this general doubt that's in there. And farmers and ranchers, for good reason, are skeptical about a lot of things, because we've been beaten over the head repeatedly a lot. So that's one So that's one of the reasons is they just don't believe it. Well, then another one is if they go to verify any of this stuff, and they go to their university or the ag extension or whatever, they start doing this and like, no, this is how you have to do it, because the universities and extension, they have this PhDs, they have a statistical analysis down to here. This is absolutely accurate. Well, yeah, it may be absolutely accurate, but you know what? A lot of it's just not true or just not necessary anymore. And I'm going to use an AI analogy now. If you start with an image, my face right here, and you put it into AI, and then you go said, hey, generate an image of Mark Shepard's face, it will be really accurate and it'll look just like my face. Well, then if that AI takes that generated image and it gets fed back into the system, you have the real image, and then you have the AI generated image. Then you go ahead, you print another one, and it gets fed back onto itself over and over and over. Pretty soon it fuzzes out and it turns into absolutely, you can't even recognize it. That's called model collapse. When you research a phenomena that was flawed to begin with, so when somebody planted apples, for example, all in one place, and a buggy comes in, they said, oh, we have a pest problem. The research comes out. The researchers study a flawed system already, which is an orchard, which is 100% apples of the same clonal variety. So they're studying a flawed system. Then they generate results. And then the next research that comes along, they're adding the flawed results back to the flawed system again and again and again. So modern agriculture is in a state of model collapse. What they are telling you is completely accurate. They're brilliant people. They care a lot, statistically significant to the nth degree. And a lot of it is just absolute plan shit. And so what I'm not an anti-intellectual, and I'm not an anti-research or any of that. I think that's absolutely vital. What I am pro-farmer and rancher, is the people on the ground who are actually doing this stuff. There is an industry around the whole organic folks who have been doing things ecologically and all natural. Some folks for like 60, 70, 80 years, they've been doing it successfully financially and successfully with, agricultural yields, nutrition yields. That needs to be studied more with equal weight as to the industrial, robotic system, that because it works.
Yep, absolutely.
And what happens when there's a supply chain hiccup? 2 years ago, there was when the whole, or maybe it was 3 years ago now, a lot of the fertilizers were being blended with reduced phosphorus in it. And they said, oh, because we're keeping the phosphorus out of the water. No, it was because you couldn't get any phosphorus in the Ukraine anymore. What happens when our critical nutrients go away and we can't get them, if you're dependent on those nutrients to get a crop, you're screwed. Whereas if we design a system that we can use some of those inputs to get increased yields, but we can do it judiciously and small amounts, precision amounts, or none at all, because we've designed a natural system with all of its complete natural cycles in place. That's a seriously economically powerful model over time.
What does the American Midwest look like in 100 years? Or I don't even want to say the Midwest. Let's say the nation. What does it look like when we're able to be successful at really implementing exactly what you're doing with RAD?
Every acre of annual crops in the USA, North America, around the world, every acre of annual crops gets restored, ecologically restored back to its previous plant community type, and ecological function, including hydrological function. And that's a small change, because it may only be just, redirecting the water a little bit, adding a few extra species of tree that are wide spaced so it looks more like a savanna, having some more perennial strips of grasses and flowers that go through the whole system. And that's a radical change over millions of acres. So to see every annual crop acres in North America and around the world converted back to the plant community types that it used to be before we started annual crop farming it.
And then advice for the acre and a half farmer. Even if someone does not have 100 acres or 20 acres, how can they apply your engineering mindset to a small plot? And when I say that, a half acre, you kind of said 5, but like those smaller guys that are like, I got this 1 acre of land in my house and I want to do this.
Well, what's great about that is, first of all, research what were the plant community types that were represented right where you live. Then mimic that from the tall trees, medium trees, short trees. And I have a couple of examples here on this farm. It's a 20-foot diameter circle with a full, complete species selection of that particular plant community type. And I planted them all at once, and I mulched them, usually with sawdust mulch, and I inoculate the sawdust mulch with Stropharia mushroom spawn. And so then as it grows, the short plants stay short, the medium plants grow to be medium, the taller plants grow to be taller, and pretty soon it just grows up like this. Now you have this deep three-dimensional structure of green catching the sunlight. You can do it on the crack between where you park the car and the sidewalk. And the proper stuff that I'm talking about, I focus mostly on food. The ornamentals, you can do all the ornamentals. That's what people are doing anyways. But I would go all different food species in that system.
Perfect. Rapid fire questions. We're coming to the end of this, Mark. Favorite tool?
Favorite tool, or my most commonly used tool? I'd say...
give them both to me.
Chainsaw and a wood splitter.
Perfect. Most underrated tree?
I would still have to say it's the chestnut. And
Best book besides your own?
Feed Us with Trees by Elspeth Hay. Elspeth Hay.
Perfect. Well, also, now that we're going to wrap this up, Mark, if you could just let our audience know where people can find you, whether that's through RAD, whatever it may be. How do people find you, your companies, your books, all of that, if you just let our audience?
So restorationag.com is how to get RAD, is the tree and shrub nursery, forestag.com. And then my books are published through Acres USA.
So to all of our audience, our listeners, if you guys would subscribe to our channel on YouTube, we have this on Apple Podcasts. We have it on Spotify. If you guys would take a look at this, like these videos, not only like them, but also, respond to them. Let's have some interaction in these. Mark, to have him on here and to give his wisdom and his education that he has over all these years and the hands-on experience is something that I can only thank you for, Mark. I appreciate your time, definitely. But if you guys would just definitely like these podcasts, let's get them out there. Let's let the world know about what Mark's doing. Not only Mark, but what's going on in this, restoration agriculture component of this industry. It's important. And not only is it important, it's going to be basically what gives our next generations the ability to continue to farm, to live healthy, to eat good food, and do those things. So again, Mark, thank you so much for your wisdom, your time. Definitely appreciate that. And again, thanks a lot to the audience for listening as well, but appreciate you.
All right. Thanks for the invite.
Absolutely. You have a great day.
You too.